Welcome to our CapStone Fall 2024 project. My name is Michael.
I'm Neil.
I'm Ethan.
I'm Wade. And I'm Glenn.
And our sponsor was MSASafety Incorporated, and they wanted us to create a design, fixture, and methodology for testing heat stress on hard hat elements. I'll hand it over to Glenn so he can talk about the mechanical aspect.
All right. So for our project, we had to create an enclosure that is fully weatherproofed and sealed. In order to do that, we took 1-inch aluminum extrusion and then as well as 1/5 inch plywood. We inlaid the plywood within the extrusion, bracketed them together to get a general shell, and then we caulked the edges as well as the inner channel in order to weatherproof it entirely. As well as that, we included a acrylic viewing panel that comes with weather stripping all the way around to ensure a seal, as well as bracketry that allows us to open it. I'm going to hand it off to Wade so he can talk about the analog.
All right. So inside of this enclosure is our human head analog. We call him Jerry. So the way he works is basically it's a 3D printed head, but on the inside is a sphere made of acrylic and it's filled with water. Both of those materials were chosen because they mimic the thermal properties of both bone, which is the skull, and the brain, which is represented by the water. And inside that we have thermal sensors submerged so that whenever temperature and environmental things are happening inside the chamber, we're seeing what's happening inside the biology of the person, and we can get reads on that. I'm going to hand it off to Ethan.
So I'm going to talk about some of the computational hardware aspects of the project. So the main computer for the whole system is a Raspberry Pi, which is controlling all the devices. So 2 fans, 2 heaters, 2 humidifying devices as well. And then it's also receiving inputs from the various sensors. So we have an atmospheric conditions sensor up at the top of the enclosure here that reads our temperature and humidity. And then we have a probe sensor, which, as Wade was just talking about, goes into the actual human analog. And that will read the temperature from within there. So now I'm going to hand it off to Neil to talk more about the software architecture.
All right, so I'm just going to go ahead and explain a bit more about the software. We have 2 Python scripts that will basically control all the testing that with the equipment inside there. And to end, we also have a graphical user interface so that our sponsor will be able to control all the items individually, as well as start and end the test and see all the desired metrics that they require. Thank you very much.
So, all in all, our project has been very successful. We were able to develop an effective test procedure and methodology for testing the various hard hat products under different heat stress conditions, and we have also developed a fixture which is able to accurately carry out those tests. Thank you for your time, and thank you for watching our video.